This is lesson 8.3, 8.4, part 1. We're going to be exploring another trig law. This time it's called the cosine law. In the previous lessons we saw the sine law. So here we have a triangle again, labeled appropriately. The cosine law, we're going to try to use it to solve for sides and angles and acute triangles again. So again, this is another situation where we are not going to have right angle triangles. We're going to have oblique triangles that are acute in this case. Remember that the angles are less than 90. Each angle is less than 90, still adding up to 180 though. And we're going to use the cosine law to do that. We can't use the trig ratios, the SOHCAHTOA, when we have these type of triangles here. So when do we use the cosine law? What can we use it for? So there's a few different situations. I'm going to point them out in this in the triangles below. You can use the cosine law when you have two sides and a contained angle. So an angle in between the two sides to find the third side. So when you have two sides and a contained angle, you can use the cosine law to find the third side. When you have the other situation is, let's say you have three sides of an acute triangle or an oblique triangle, and you want to find any angle within. Well, you can do that. You can use the cosine law if you have three sides and you want to find any of these angles within here. So that's what the cosine law allows you to do. The sine law did not necessarily allow you to do that. For the sine law, you had to have two sides and an angle opposite to those two sides, or two angles and one of these sides had to be opposite to one of those angles. Whereas here, if you have only three sides and no angles, you can use the cosine law to find an angle. Or if you have only two sides and no angle opposite but an angle contained, then you can use the cosine law as well. So this is just another tool that we're adding to our repertoire to be able to solve for triangles when we don't have everything given to us. So how is the cosine law written out? Well, again, for a triangle ABC, this is what it looks like. So c squared would be equal to a squared plus b squared minus 2 times a times b times cos of angle C. So notice that the side that's isolated here is going to be equal to the sum of a squared and b squared, so a squared plus b squared, so the other two sides, minus 2 times the other two sides cos of the angle that's isolated. Let's say, for example, we want to write this relationship in terms of the side A. We'd write a squared is equal to the other two sides, so b squared plus c squared minus 2 the other two sides, bc, cos of angle A. And if you want to write it in terms of b squared, you would write b squared is equal to the other two sides, so a squared plus c squared minus 2 the other two sides, ac, cos of angle B. And so you can write it in any of those three forms. And the important point I want you to get is that you can actually use these three forms to solve for a certain angle if you wanted to. So let's say I want to solve for angle C. To do that, I would isolate cos C. I would do c squared is equal to a squared plus b squared minus 2ab cos C. I would subtract a squared and b squared from both sides, so I'd get c squared minus a squared minus b squared is equal to minus 2ab cos C. I would then divide both sides by minus 2ab, since they're all multiplied there, ab. And so what I would get is cos C is equal to c squared minus a squared minus b squared over negative 2ab. Now remember that this is not angle C yet. It's not angle C yet. To find angle C, you would have to do the inverse cos of that above there, of the C squared minus A squared minus B squared over negative 2AB. And so that would allow you to find that angle there, angle C. And you could rearrange all of these equations in much the same way. So I'd recommend you practice rearranging this equation here to try to find angle A, and this equation here to try to find angle B. So let's try one of these situations out. Let's do example 1. So we have a situation where we have two sides and a contained angle. And we want to find the length of CB. So when we say length CB, that means the length from C to B. The length from C to B. This length over here. And so we're going to call that little a, because big A is over here, so it's the opposite side. This would be little b, and this would be little c. So make sure you match those letters properly. Again, we want to find little a. So our formula is going to be a squared is equal to b squared plus c squared minus 2bc cos A. And we can go plug in our numbers. So a squared is equal to b squared. So b squared is 32. So 32 squared plus c squared, so 40 squared, minus 2 times 32 times 40 times cos of angle A. Angle A is 58. Once again, your calculator needs to be in degrees mode. So a squared is equal to 32 squared plus 40 squared, 2,624, minus, so 2 times 32 times 40, minus 2560 cos 58. So that means that a squared is equal to, now normally I wouldn't write a squared over and over again. I'm just doing this to remember that at the end I don't have a right away. I need to square root it after to get a, just to remind myself to do that. So let's do 2,624 minus, open brackets, 2,560 times cos 58 in degrees mode, close brackets, and I get 1267. I'm just rounding down. And so that means that a is going to be equal to square root of 1267. Therefore, a is going to be about 35.6, so 36 degrees. Nope, not 36 degrees, sorry, 36. We're looking for a side here, so 36 meters. And so there we use the cosine law to find a side when we had two sides and a contained angle. So now we're going to start example number 2. I'm going to erase example number 1 so we have some room. But first I'm going to start the setup here. So notice we have 3 sides but no angles, and we want to find this angle here. So it's the other situation for the cosine law. So I'm going to name these vertices. It doesn't really matter what you name them. I'm going to name this one A, this one B, this one C. And so as a result of that, this is little a, this is little c, and this is little b. So label those triangles. So let me erase the work here. You can always go back and rewind to find it. So we have room to do the work for example 2. Okay. So in our situation here, we're looking for angle B. X is angle B. So we're going to write our formula out. And this is again for example 2 here. We're going to do B squared is equal to A squared plus C squared minus 2AC cos B. We're looking for B here. So we're looking for. So let's start filling in our numbers. We do have B, so 41 squared is equal to, we have A, which is 21 squared. We have C, which is 31 squared. Minus 2 times A was 21 times C, which is 31, cos B, and it's 31 there. So let me start simplifying now. So I have 41 squared. So 1681 is equal to 21 squared plus 31 squared. So 21 squared plus 31 squared. So 1402 minus 21 times 31 times 2 minus 1302 cos B. And now I'm going to start simplifying stuff here. So isolating rather. 1681 minus 1402. I basically just sent the 1402 to the other side. Is equal to negative 1302 cos B. So if I do 1681 minus 1402, I get 279 is equal to negative 1302 cos B. Divide both sides by negative 1302. So divide both sides by negative 1302. And I get negative 0.214 is equal to, I'm not going to round too much here, I'm going to leave 3 decimal places there, is equal to cos B. So to find angle B, I'm going to do the inverse cos of this negative 0.214. In reality, I'm actually leaving the whole thing on my calculator. I'm leaving the whole thing on my calculator, and then I'm just going to do the second function of cos, put in my answer, and I'm going to get 102.37 degrees. I can leave it 3 decimal places, depending on what I tell you. So 373 or 374 degrees. If I were to round that just to the nearest degree, that would be again approximately 102 degrees. And so all I did here was arrange my formula from its basic form that you see here, its original form using the sides, and then I solved for B by solving for cos B first, and then to find B, the angle itself, I had to do the inverse cos. Typically I leave the entire answer in my calculator and then I just do second function answer, and that gives me a close answer to what I'm looking for. So those were basic examples of using the cosine law. In the next video we're going to apply the cosine law to some word problems.